So I will tell about myself first. So myself, Mohan. I have 6.5 years of experience working in the IT industry. I majorly worked on data science. Okay. Apart from that, I also have working experience in teaching. Okay. As a part-time, I teach students. Okay. My main background is mathematics and statistics and deep learning, computer vision, ML, Python, etc. Okay. So while learning ML, okay, I got the interest for teaching from my professors. Okay, the way they teach. Okay, it's not that every teacher teaches in the same way. So my teacher, I inspired actually from the way or the style they're teaching. I got inspired, and I started looking for the opportunities as a trainer. Initially, I have to prepare the curriculum, prepare the notes and all, and then I eventually came into training. So far, I handled more than 10, 15 batches. Down also there is one institute. Okay, I handled 3 batches there. Okay, recently I got an opportunity with AimNxt. Okay, so we are here for data science, right? So we are here for data science. Okay. So what do you know about data science? Anyone?
Finding patterns in data
Finding patterns in the
to
data
optimize result
to
or
optimize the
revenue,
result.
something like that.
Okay. Feel free to answer. Make the interactive. Try to learn more. Okay. So if you ask me, what is data science? Okay. Data science is a discipline or principle. Okay. Which uses set of tools. Which uses a set of tools to solve a business problem. To solve a I will give you one simple example of how a business problem will look like and how data science will try to help you solve it, and what are the tools that are used to solve that problem and how we are going to learn in this course the tools I will tell you. Okay, what is the agenda? There will be a business problem. Okay, how this business problem will look like. So once there is a business problem, we have to solve this problem. So to solve this problem, we'll make use of data science. So data science is a collection of tools and techniques. So how data science is going to make use of these tools and techniques to solve this business problem. And in this course, how we are going to learn these tools is something I'm going to explain. Understood the agenda for this demo session? Okay. First of all, I will tell you the tools that whatever we are going to learn. Then I will try to tell you a simple business problem and how to make use of these tools, and we will solve the problem. Okay. So the data science is a collection of tools. The first set of tools you need is any programming language. Any one programming language. Okay. So what programming language we have? Tell me. C we have, C++, we have Python, we have Java, we have we have many other programming languages. Okay, we have one more thing called R. Okay. We have one more thing called R. Python, Java, R. Okay. The most popular data science languages are Python and R. Okay. These two are very popular. Why they are popular?
They have been built libraries.
Yeah. So they have vast set of libraries. Okay. They have vast set of libraries. What do I mean by libraries?
A set of pre-written functions that we can use.
Yes. Okay.
To reduce our workload.
I will give you a simple example. What is a library? And we have many such libraries in Python, especially to work on data science. Okay, especially to work on data science. If you have any questions, feel free to ask me at any point. Okay, stop me right there. So let's say there is a car. Okay, there is a car. What are all the functions that a car can do? Tell me.
Accelerate,
drive, brake, horn, lights, gear shifting. There are many functions that. Okay. Now, if you try to wrap all these things into one thing, that is called a module kind of thing. Okay, that is called a module. Similarly, in the Python, okay, there are several libraries. So if you know arrays, right? Now arrays or matrices. To work with matrices, there is a dedicated library in Python that is called NumPy. That is called NumPy. Stands for numeric Python, only to work with the arrays and the matrices. What is an array? You know, right? A collection of similar data types. Okay. So to work with the tabular data, what is a tabular data? If you know Excel sheets, SQL data tables. Okay. To work with the tabular data, we have a specific library called the pandas. To work with images, the image also is a data, right? So this is a structured data and images is unstructured data. So to work with structured data, we have NumPy and pandas. To work with unstructured data images, we have something called CV. Stands for computer vision. Vision means vision, something we can see. We are using computers to work with vision related problems. So that library is called computer vision. There is something called text. What is text? I'm speaking. I'm speaking, right? So this, if you record this everything and you try to convert into a text, it is a text data, right? So let's say I have an email. Email is a collection of text, right? So if you look at your Gmail, they will divide these emails into spam, junk, and good emails, correct? How they will do that?
Natural language processing.
By using they will collect this text and apply this data science related solutioning, and they will try to divide this into whether it's a spam email or ham email. So to work with the text data, we have a specific library called NLP. NLP. Get it? You're getting? Yes. Okay. So to work with so there are many other things. So to work with web applications, we have something called Flask. What is web application? So this is a web application, right? So API programming. What is API programming? Application programming interface. So let's say you are requesting facebook.com. Let's say if I click on new tab and if I'm writing facebook.com, what it is going to do? There is a Facebook server, right? In the Facebook server, there is a HTML page. You know HTML? Yes or no? So from the Chrome browser, you are sending a request to this Facebook server, and it will return you a page, and this page is displayed on your web browser. So this request and response need to be carried out by some application program. This request and response is nothing but the application programming interface. So you have in Java, you have Spring, Boot, and Hibernate. In Python, you have Flask, Django. So Python has a different set of libraries to work on different set of problems. Okay, if you want to work with GUI, what is GUI? Tell me. Graphical user interface. So there are two set of applications. One is web application. One is desktop application. What is a desktop application? Tell me. This Chrome is a desktop application. Facebook is a web application. You have desktop version also. Facebook, you have both desktop version and the web version. So to work with the desktop related applications, you have something called a library, a dedicated library called TK-Inter. TK-Inter. So Python provides a vast set of libraries. So we are going to learn, what is the first thing we are going to learn in the data science? Python programming language. Why do we need a programming language? Tell me. Okay, this is providing all this, but what this Python will do?
Provides a computer set of instructions to execute.
Yes. In the Python, we are going to write a set of instructions. Instruction 1, instruction 2, instruction 3, instruction 4, instruction 5, instruction 6, so on. So this set of instructions, it is going to take and execute and provide the result for you. Okay. So that's what in simple Python is all about. Understood what is Python and why we are going to use the Python? If you ask me in specific to data science, we will learn NumPy, Pandas, sklearn. Sklearn is a machine learning library. TensorFlow is a
Deep learning library.
deep learning library. Keras, PyTorch. So Keras and PyTorch are the deep learning libraries. Okay, I will tell you what is difference between machine learning and deep learning. I will tell you down the line. So initially, let's try to understand what is Python. Clear on what is Python? Yes. Clear?
Yes.
Okay. The second thing we are going to learn is in the curriculum, if you see. So this is the curriculum.
Online
So let's have a look at the curriculum, and I will try to explain what exactly we will go through. Okay. Yeah, this is the curriculum. Initially, what we are going to learn Python for machine learning. Okay, in the Python for machine learning, we will cover the basics of Python. How to install Python on your laptop. Okay, how to work with the basics. Okay, variables, data types, built-in functions, operators. Anyone know Python before? You? No? Any other programming language? No? But it's okay. I will cover from the basics. You don't know any programming language? Basics, you know, you basics, you know. Okay, I will cover. Don't worry, I will cover all the basics. Okay, so how to install Python? What are all the variables, data types? Okay, how to work with numbers? How to work with strings? How to work with Boolean means true false? How to write a function? What is a function?
Set of useful code.
So let's say you want to do a sum of numbers. Okay, so every time you don't write 1 plus 2 plus 3. So and instead you will write a function that takes some numbers and it will do the addition and give it to for you. Okay, all the repeated tasks what we are going to do, we are going to write in the form of functions. We can reuse that function any number of times. Okay, operators, type conversions, user input. Okay, control flow like if else expressions, looping, how to loop. Okay, what are the data structures that are available, list, set, tuple, dictionary, what are the different functions that are available. Okay, and then the simple list comprehensions. This is all whatever that is required for the data science we are going to learn in the Python section. Okay, then we are going to learn the NumPy. What is NumPy?
Used to work on matrices.
Yeah, it's a numerical Python. NumPy stands for numeric Python. All the scientific calculations, all the mathematical calculations. Tell me different mathematical functions you know. Any mathematical function.
Absolute function.
Absolute is a function. Exponential,
Sine, cos,
sine,
tan.
cos, power, tan.
All the other ones for tan.
Any.
Cosecant.
There are many functions available. So all these functions are available in this NumPy library. Okay, we are going to make use of NumPy library to do all the mean, average, median, standard deviation, variance. Okay, all these are there in the NumPy module. Okay, and the matrices to work with one-dimensional matrix, two-dimensional matrix, 3D matrices. Okay, so how to work with matrices and all we are going to learn in the NumPy module. Then the pandas module. What is pandas?
You should work with data sets.
Tabular data. So let's say you have an Excel table. Let's say you have a group of students and their marks. So how to compute the average? Okay, student wise, if you want to do an average, what is this average marks? What is the percentage you want to calculate? Subject wise average if you want to compute. Okay, so likewise, so let's say you have a data like this: student 1, student 2, student 3, and his marks in science, social, Telugu, etc. If you want to compute the average of the student or overall class, what is the average on Telugu? Likewise, if you want to compute to work on tabular data, we'll make use of the pandas. Okay, then we'll come to the data analysis. Okay. Here. Any questions so far? Any questions? Yes, no? No? Any questions? All good. Okay. So from here, I will go very slow. Listen very carefully. Okay. So Python is very basic, so that's why I was a bit fast. So from here, I will go very slow. Okay. Okay. So far what we learned the Python basics. Okay. So using Python, what we will do?
Short screen sharing.
Okay. So using NumPy and pandas, what you will do, you will get the data. You will get the data. So let's say I have a data that looks something like this. Okay. So this is a table of data. Let's say I have student 1, student 2, student 3, student 4, Telugu, Hindi, maths and science. Okay. Let's say I have marks that look something like this. Okay. Now I want to help this guy. Okay. So let's say you have marks of unit test 1, unit test 2, unit test 3, unit test 4, quarterly, half yearly, and final. Finally is not yet done. Okay. Finally is not yet done. I have marks of all these examinations. Okay. So this particular student 1, I will take this guy's Telugu scores average and I will see Hindi, maths, social. Okay. I will take this subjects average. And if this guy is performing poor on Telugu, what I will do? For the final exam, I will ask him to concentrate more on Telugu. Yes. Similarly, if this guy is performing poor on Hindi, I will ask him to concentrate more on Hindi. Similarly, I will do the same for maths and science, social, etc. Okay. Now, in real time, the data will be not this much straightforward. Okay, it will not be straightforward like this. Yeah, there will be. So now I will give you a simple example. Okay, of what a machine learning is. What will come next?
5. Parallel regression.
5. How you are able to tell 5 will come?
Plus 1.
So it's a arithmetic progression, right? It's simply a plus n minus 1 into d. You read, right? The progressions you read in your childhood basic mathematics. Okay. Now let's say I will give 3, 6, 9, 12. What will come here?
50.
50. You are able to tell. Okay. But what will come next?
Not to calculate FTS regression methods.
What will come next? You can't tell, right? You can't tell. Why I can't tell? Tell me.
It's not a simple arithmetic progression.
There is something called data and there is something called information. Raw data and information. What is a raw data? This is a raw data. Okay. Raw data contains noise, missing values, some unwanted data, etc. Okay. So the raw data contains some noise, some missing values, some unwanted data, correct? So what we have to do? We have to prepare the data and extract the information. Okay, we have to extract the information. So what I can do, tell me here, to extract the information? Any simple mathematical function I can do, and any simple mathematical function.
You can average the difference between each values and then add the progression.
Okay, any simple. Let's try to make it simple. Can I apply round? You know round function? You know round function? No? No? What is round? It will eliminate the part. It will eliminate the decimal part. So if I round this, what I will get? 3. If I round this, what I will get? 6. If I round this, what I will get?
9.
If I round this, what I will get?
13.
13 I will get. Let's make it 3, 4. Now what I will get? 12. Now 50. So by doing simple data preparation, I'm able to reduce this noise. So this is the noise that is present in the data that is obstructing me from identifying the pattern that is present in the data. So I have to remove the noise. There are several techniques, but just to help you understand, the raw data is not useful for the data, the pattern finding. We have to do the extract the information. Okay. So there are several techniques. The techniques is called the EDA. The techniques is called EDA. So there is a module called EDA in your exploratory data analysis. Okay, using all these techniques, we will try to extract the information from the data. Okay, but how to identify this? So to identify this, we'll make use of some visual analytics and the pandas. We will make use of some visual analytics and pandas. Okay, so how to identify this? I'll give you a simple example. Okay, so let's say I'm collecting age of the students in a class. Okay, in a 10th class. Okay, age of the students. Tell me what is the average age. Let's say I can see 13, I can see 14, I can see 15. At max, I can see 16 and 12. But if I'm doing something 26, if I'm observing something 26, what does this mean?
Outlier.
Yeah, something unwanted data is there, correct? Okay, there is some unwanted data that is present. So this can be coming from any way. Okay, there is some admission guy, he might have done some mistake. Instead of writing 16, he might have wrote 26, right? So people can do mistake. So while collecting the data, people can do mistakes, right? So instead of entering 16, he entered 26. I cannot proceed further with this kind of data, correct? Yes or no? So I have to identify such data. So how I will identify? I will make use of the data analysis. I will make use of the data analysis, especially visual data analysis. So in the visualization, I will make use of some graphs. Okay, I will try to put a line graph. Okay, I'm expecting a graph like this, but instead, if there is a 26 here, there is a problem with the data. Correct? Yes, sir.
Should be a scatter plot.
Yeah, I can do a scatter plot as well. Scatter plot also can do. Now, if I start talking scatter plot, box plot, we'll get confused. Simply, I will tell you. I will make use of graphs. Okay. So to calculate the percentage, student percentage, I will make use of the graphs. Okay. So Telugu, Hindi, English. This is a pie graph. You might have learned in your childhood. Okay, social. So if the graph area is very less, which means that particular student is performing poor in this particular language. Okay. So I will make use of such graphs and I will try to do the data analysis part. Okay. Here we need something called the visualization, right? In the pandas, you have a library called the matplotlib for the visualization and cbomb. cbomb. So don't worry, we will cover everything, but just I'm trying to tell you what we are going to learn in the course. Okay, so how we are going to do, what is this graph and all, don't try to comprehend. You will not get it now, even if I tell the names. Just understand we are going to learn the basics of Python to work with the data. We are going to learn NumPy to work with the numerical related computations and the matrix operations. We are going to learn pandas for the tabular data, work with the tabular data. We are going to learn visualization for the data analysis. These two libraries we are going to use, okay, for the data analysis, especially to identify such noise and the noise and the outliers, etc., that is present in the data. And to fix those issues, we will make use of the EDA, exploratory data analysis. In the exploratory data analysis, we will mainly use the maths and the stats. The maths and the stats. Understood till here? Any questions? Yes, no? Any questions? Good, all good? Okay. Now that you done till here, the EDA part, next is the statistical data analysis. Data analysis. What is statistical data analysis? Listen very carefully this point. The statistical data analysis. Okay. Let's say you are given some data. Okay. You are given some data. Okay. In a class, let's say I have 100 students. Okay. 100 students. I have 30 females and 70 males. Okay. 70 males and 30 females. Okay. But in the real time, 50-50 will be there. Okay. Okay. Now let's take like this. Let's say you were given some hospital data. Let's not take about the class data. Okay. Hospital data. You are given the patient information, patient name, the disease he's having. Okay. Is diabetic? Yes, no. Whether he's a diabetic or not. Patient 1, patient 2, patient 3, so on up until patient 1000. Yes, no. You know diabetic, right? Diabetes means what? Sugar. Whether he is having sugar or not, you are given this information. Okay. Now, in the real, every 100 patients coming to the hospital, 80 will be non-diabetic, 20 will be diabetic. Okay, which means what is the ratio? 8 is to 2, correct? 8 is to 2. But the data I was given is having 6 is to 4 ratio. What is the meaning of this? What is the meaning of this? Data is not correctly representing the actual data. Okay, this is a wrong representation. Okay, which means what? I cannot go ahead and do analysis with this data because I should have correct data, correct? There are many such examples. If you take a civil, if I take the students male to ratio, every 5 boys there will be 1 girl. But if I take IT, every 6 boys there will be 5 girls. Correct? In the civil there will be very less girls, right? And mechanical. So my data should be, and let's say if I have given some age information of a BTech students. So the age range will be from 20 to 15, 17 to 23 is accepted. But if my data is saying 26 is the mean age, see, the data is not correctly representing, correct? The data that is present here is not correct. Yes or no? So there are techniques to identify this. Such techniques are called the statistical data analysis. So we'll use some tests here, statistical tests. There is something called mean test, proportion test. I will not tell the names now. You will get confused. This type of checking is called what? The data reliability. Means how reliable is my data? Understood? How reliable is my data? So to check this reliability, we have something called statistical test. This is very, very simple actually. The naming itself is the complex one, but the testing is very simple. So that we will not, so we are given some data. We have extracted the information. Now my data is good. Now I want to go ahead and try to identify the pattern. But I have to check whether this data itself is good or not, correct? Is reliable or not. If he's giving some 6 is to 4, I cannot go forward. I'm expecting 8 is to 2, but you are giving me 6.4. No, I can't go proceed further. So to identify this, I will make use of the statistical data analysis. Understood why we use statistics? To check the data reliability, whether my data is correct or not. Understood? Once you feel that your data is good, now you took the data, you did all your data preparation using EDA and you fixed the data, you extracted the information, and now you completed the data reliability. You understood that your data is good. Okay. Next comes the machine learning. Next comes the machine learning. Before I tell what is before what we will do in the machine learning, let me give you an understanding of how a machine learning problem will look like. In simple, I will tell you how a machine learning problem will look like. I will tell you. Pay attention. Let's say I have a company X. Name some companies, any companies. IT, huh? Infosys. Okay, let's say Infi. Any other? Wipro. Wipro. Okay. What does this company contains? Employees, right? This contains employees. So let's say I have some data. Employee 1, employee 2, employee 3, employee 100. Employee name, name 1, name 2. What is the information that these employees contain? Age. I can contain age, right? So employee ID, employee name. I can have age, correct? So let's say 26, 25, 31, 40, 40. Let's say I have information like this. What else I can have? Gender. Male, female, male, female. And experience. Very good. Experience is the important. 3, 4, 10, 12. Salary. $1,000, $1,500, $2,000, $2,500. Okay. Now this company, this particular Infosys company, let's say tomorrow there is a person joining. Okay, tomorrow there is a person joining. Okay, let's say employee 101 with the so and so name, with the 28 years of age, is a gender male, with the 6 years of experience. What is the salary I should give to this person? Okay, I have this information, okay, and I can also have the designation, uh, that education level, B.Tech, PhD, graduate, masters, etc. And I can also have the designation data scientist, Java developer, AWS developer, etc. Okay, given all this information, I want to understand what is the salary I can give to this person. Okay, what is the salary I can give this to this person? What I will do? How can I solve this? Tell me. How you will approach this problem?
Finding the correlation between experience, designation, education level, and salary.
So I want to understand what is the salary due to the person. What I will do? So I will take. So let's say his designation is data science. Okay, I will take all the data science employees from this entire data. I will only take the data science employees. In specific, I will take the employees with 4 to 8 years of experience. Okay, there might be experience from 0 till 20. I will only take this range, 4 to 6 years of experience. Okay, and I will only take the education's B.Tech because this guy did a B.Tech. I will take the B.Tech guy, and gender also I will take only male gender because this is a male guy. So I will try to filter the records and I will try to see what is the average salary of this particular group. Understood? I will logically group this data and try to see the average salary, and I will try to tell, okay, this much salary I can give to this person. Understood? This is one way, correct? This is one way. This is very crude way. This is called a crude way. There might be many other factors that might impact his salary. Okay, there might be many other. So this is a problem that machine learning can solve. This is a problem that machine learning can solve. Okay, don't get scared. Okay, so salary is a function of experience, designation, education level, gender, region. There might be many other factors that is contributing to the salary. Understood? Now what I will do, I will make use of some ML algorithms. There are many algorithms in machine learning that can solve this problem. Yeah, many problems. There are many algorithms that can solve this problem. We will make use of ML, and whenever a new guy comes, I will give that guy's information to the ML. This ML will tell me how much salary I can give to this guy. Okay, this can sometimes be correct, this can sometimes be wrong, but there are some testing. You can do the testing also whether this model is correct or not. Once we feel that this ML is good, then only we will use that. Okay, so this type of problem. So this is a business problem. In the very beginning, if I'm telling about the business problem, right? There are many such problems. Okay, there are many such problems. So this is one type of problem. Any other problems you can tell? Try to tell one problem that similar thing. So diabetic, yes, no. A patient is coming to my hospital. Okay, so he's having so and so age, blood glucose level. I will check his blood pressure. Okay, and body mass index, weight, height. So I will consider all these attributes. I will tell whether this person is having a diabetic, yes, no. Okay, so let's say there are some 1,000 patients coming to the hospital. Okay, on a daily basis. Out of 1,000 patients, only 10 people are diabetic, 990 people are not diabetic. Because to test this diabetic, there is a lot of tests that they have to do and confirm whether. But see the business that they are getting, only 10 people business they are getting out of 1,000 tests they are doing. There is a lot of manual effort that is there, right? To reduce this manual effort, you can make use of ML. You can simply give this person's information to ML. This can tell whether this is a diabetic or not. This manual effort is being reduced. Okay. How this ML will understand? So this particular data will have some pattern, correct? This particular data will have some pattern. So this pattern, this hidden pattern that is being extracted by the ML. ML has the capability to extract the hidden pattern present in the data. Okay. Now you understood what is a business problem and how this ML can solve. Okay, there are many flavors in this. Okay, again, don't get scared. There is something called regression. There is something called classification. There is something called clustering. We will discuss this in detail if you go to your ML curriculum. Okay, initially is the regression, then is the classification, then is the clustering. Okay, so we will make use of the ML and try to solve such problems. Okay, initially it will try to extract this is called past data. So it will try to understand the pattern that is present in the past data. Whenever there is a new things coming, it will try to predict the how my outcome is going to be for the new data. Any other problems you can tell, like problems that ML can solve? So let's say I have an image, person, and I have a dog. Okay, let's say
So common deep learning can't do the machine.
you can do with ML also. So I will give this image to ML algorithm. It will tell me whether this is a person or a dog. Whether this is a person or a dog. Let's say I will give speech, whether a male is talking or female is talking. It can tell whether a male is talking or female is talking. These are very simple. Don't think these are highly complex. Okay. After all, this is a data. After all, this is a numbers. Okay. Numbers contain pattern. ML can extract the pattern. Okay. Don't think this is speech means it is some audio file or audio. Even image, don't think this is image. This is a array of numbers. What is an image? It's an array of numbers like 10, 15, 20, 256. 256 means white. 10 means black. Okay. So it is nothing but array of numbers. Even speech is also an array of numbers. Okay. And the numbers means data. Data contains pattern. Your ML can extract the pattern. It's a male or female, it can tell. Even text also, don't think it's characters. Even text also is converted into numbers. Not ASCII. There is a way to tokenization. Yeah, there are many flavors in the text actually. So text is also presented as numbers. So you take your email, try to give it to ML model. It will tell you whether it's a spam email or a good email. Okay, spam email or a good email. Any other example you can tell related to text in your daily life that you are seeing? What is that? Word embeddings is a data preparation technique. So let's say there is a movie that came today. Okay, let's say the Pawan Kalyan movie or the Prabhas movie. People will write reviews, right? Whether I can tell it's a good review or a bad review. Let's say there is a person writing, the movie is very good, which means it's a good review. The movie is pathetic. The review is a bad review, correct? I can do that using ML. ML and DL I can do. Okay. So there are many problems that can do. Okay. But continuation to machine learning, there is also something called deep learning. Okay. Both does the same thing. It will try to solve this kind of similar problems. Okay. But the techniques they are going to use is different. What ML will use? ML will use the mathematics based methods. What this deep learning will do? Deep learning in simple, it will mimic. Mimic means what? Imitate the human brain. Your human brain can solve a problem, right? Yes or no? So deep learning will try to imitate or mathematically model the human brain. It's very simple. It's not highly complex and all. It will try to simulate. It will try to simulate the human brain, but it can do only one task. It cannot do multiple tasks. Okay, your human brain can do multiple tasks, right? But your deep learning can do only one task. Okay, you can develop a model to do one task. Okay, that's about the machine learning and deep learning. There are many things in this. Everything is similar to connectivity actually. Okay, machine learning connects to deep learning. In the machine learning, regression connects to classification, connects to clustering. In the deep learning, there are three flavors. Okay, there is something called CNN, RNN, ANN. Don't get scared by the terminology. They are very simple. Okay, all are trying to do what? Solve a problem. Solve a problem, a business problem in specific that a human needs a manual effort. They are trying to automate this. Okay. So that's where your ML and DL comes into picture. Okay. Going to the beginning, we started with Python, NumPy, Pandas, visualization. This is a data analysis techniques. And then there is something called EDA. And then there is something called stats. And then there is something called machine learning. And then there is something called deep learning. And then there is something called deep learning. This is what we have seen, right? Now I will try to expand this one. Let's try to expand this part. What is ML? What is DL? ML, we have something called regression, classification, clustering, deep learning. Let's come to deep learning later. What is regression? I told, right? We are trying to understand salary. Okay, salary is what? Numerical, correct? Numbers. If you are working with numbers, it's regression. Diabetic, yes, no. Categories. This is called a categories, right? If you are trying to understand categories, that is called a classification. What is clustering?
Same but with unlabeled data. Grouping.
Grouping, similar things. Okay. How to what? Give me a simple example of grouping.
That's kind of what we can do grouping very easily.
Let's say there is a species of flowers, correct? Species of flowers, or let's say there is a kind of cricket. You know cricket. So there is something called batsman. There is something called bowler. There is something called fielder, or let's say both batsman and bowler, like all rounder. So I have a data that has summary whether he can bowl or not, bat or not, how many runs he scored, how many type of wickets. So based on this information, I will try to group this particular person as a batsman, or he's a bowler, or he's an all-rounder. I will try to group similar things together. Group similar things together. If you take the students, good, average, poor. Good, average, poor. If you try to take the cars, luxury cars, middle, and economy cars. Okay, economy cars. I have some car information, price, or houses also. There is something called luxury houses, like that. So in all these things, what we are trying to do, we are trying to group similar things together. Group similar things together. That is called as the clustering. Okay. To achieve this, we have algorithms. There are. I will simply tell the names, but don't get scared. There is something called linear regression, the gradient descent algorithm. There is something called random forest, decision tree, k nearest neighbors, logistic regression. Very simple. These and all are very simple, no complex. Okay. Don't think these and all are complex. Only the names are complex. Okay. Implementation is very simple mathematically. Okay. Clustering, you have something called hierarchical clustering, density based clustering. Okay. Huh? PCA, principal component analysis. It's a dimensionality reduction technique actually. So this is it about the machine learning. But machine learning will mainly work with the structured data. What is structured data? The tabular data is called structured data. In deep learning, image, text, time series. This is called unstructured data. So to work with unstructured data, we will use the deep learning. For images, you have a special CNN, convolutional neural networks. To work with the text, you have something called recurrent neural networks. Time series, you can make use of both RNN and time series. And this tabular data also, you can implement deep learning. That is a special thing called artificial neural networks. Okay. To work with tabular data, you will use artificial neural networks. To work with images, you will work with CNNs. To work with this time series and text data, you will use recurrent neural networks. Okay. So that's where our course concludes. So introduction to deep learning and all. Computer vision is especially for images. Text and time series we will understand separately. Okay. So this is your ML curriculum. We will understand regression, we will understand classification, we will understand clustering, we will understand the case study, and then we will move to the artificial neural networks, AI. We will understand deep learning, computer vision. This for text and time series, there is a special flavor. We will try to study this. Okay. So as a whole in the course, you are going to learn all of these things. Now I believe you have an understanding what are all these tools are, and what we are going to learn, and how we are going to learn these tools to solve a problem. Any confusion? Anyone? No? Clear? See, coming to the course, okay. Initially, I will tell you the theory, and then I will tell you the maths, and then I will tell you the coding, and then you should practice. This part is yours, okay? Practice part is yours. So this one is what? theory. This one is what? Maths. And this we have to implement in the code, correct? This we have to implement in the code. What is theory? Let's say there is a concept called regression. What is regression? Why do we need this? How to approach this and all I will tell you. And to solve a problem, we need maths, right? That's where I will tell the maths. And this maths supposed to give in the form of instructions, right? So there is a data and there is some maths, and you have to apply this maths to this data, correct? So
don't have to all that.
Huh?
We just follow the
Ah.
function.
yeah, we don't need to do everything. You have all the functions available, but you need to know these functions, right? What function I have to use and where I have to use which function. So that I will tell in the form of coding. Okay. Now in simple, what is data science is all about? I have a data. I have my mathematical knowledge. I have to apply this maths to this data using Python programming language to solve a problem. Yes, I have a data. I have the mathematical knowledge. I have to make use of Python and apply this maths to this data using the Python programming language to get a output. That's where we are solving the business problem. Understood? Clear? Make sense? Yes. Okay. Yeah, it's for you now. If you have any questions, I can take. I said right. So these two are the curriculum I'm going to cover. Right from the starting, Python fundamentals and basics I will cover, whatever that is required for the data science. Okay. NumPy. Yeah, lambda functions I will cover. List comprehension, filter map reduce. Okay. These are the data structures, control flow, type conversions, built-in functions, variables and data types, starting with number strings. Installation. What is installation and how to work and all. And then how to work with NumPy, and then pandas, how to work on visualization, how to work on data analysis, statistical data analysis, machine learning, regression, classification, clustering, and then a case study, end-to-end project. Okay, how to make use of all these things at one go in a one project, how you will use from end to end, I will tell you. See, if you are curious, bring your own data. Okay, and then try to work on your own problem. I'll help you out. Okay, it's not that I will tell and you have to do only that. I will tell you where you can get the data, and you try to get your own data, and then try to each one of you pick up one data and try to apply this any one of these techniques, and I'll help you out wherever you got stuck. Okay. Even this deep learning also, computer vision, text and time series, I will tell you where you can get the data. Try to get the data and try to solve the problem. Okay, how you will approach. It's not about you are solving the problem. It's about the approach. Okay. Every problem you cannot approach the same way. Okay. You have to use a different okay, I will tell you one simple example. Okay, there is something called sales, and there is something called demand, and there is something called profit. Okay, 10,
Supply.
10 supply. So I have a demand. Let's say there are 10 people asking for laptops, but I have 20 products. What happens to the price?
It reduces.
It reduces, correct? Let's say the supply is 20, but the demand is 30. What happens to price?
It reduces.
Increases, correct? But tell me whether I will get a profit or loss. If I take supply to demand ratio, okay, supply divided by demand, okay, what is 10 by 10? 1. What is 20 by 30? 0.6. Let's say 30, 20, 1.5. If the supply to demand ratio is less than 1, what happens? Greater than 1, what happens? Equal to 1, what happens? If it is equal to 1, no profit, no gain. If it is less than 1, I will get higher profit. If it is greater than 1, I will get loss, correct?
That's not always true. It depends on the price of product.
Remaining, assuming the price is constant. Okay, assuming the price, production cost and price is constant. Okay, on a higher level, I'm trying to help you understand what is the power of approach. I'm trying to help you understand what is the power of approach. See, how do I know I have to take supply to demand ratio?
Because it influences the price and price influences the profit.
There is something called the domain knowledge. What is the domain knowledge here? As see, if this is a sales domain knowledge, correct? There is a sales domain knowledge. How do I know how to take supply to demand ratio? because I know the domain knowledge of sales. I know this formula. Okay. I will give you one more example. Now you will understand better. Okay. Let's say I have a information of cars only moving in the Madhapur region and their speed and time and time. I want to understand which of these cars are overspeeding. Which of these cars are overspeeding? How will you do it? Every question is a very interesting interview question. Okay, think of it like this. These questions they ask me in an interview. In the Madhapur region, there are some 1,000 cars going. I have the information of the speed and at what time they are going. Okay, I want to understand which of these cars are overspeeding. How will I understand?
We have to have time series, right? Not just one time problem. We have time series and we can.
No, it's not time series. It's simple data. No, not computer vision. It's simple tabular data. I have car 1, car 2, speed 60, 70, 80, and time 10, 10, 11, 11, 11 AM like that.
Compare all cars at 10 and then check which one is higher speed level. Speed. Is that
So,
what you're saying?
okay, you took all the 10 cars. Okay, let's say you got some 100 records. How you will know which of them are overspeeding?
In the mean speed and
The approach. See what it is doing. He's trying to take see 10 is the busiest period, right? And 11 is not the busiest period. I cannot compare entire average. If I take entire average, what will happen? 10 o'clock, the cars will move slow. Why? Because it's a peak time. Because there will be there will be more traffic. The cars will go slow. And 11, it's not the peak time. The cars will go a bit faster. Correct. So I have to logically group the data. So 10 o'clock, I will group, and I will try to compute the average. If I take the average, my average speed is let's say 50. Anything that is going above 50, I will consider as overspeeding. No, why 50? I will try to put a threshold. 40 to 60, I will tolerate. Anything beyond 60, I will overspeed. Now, instead of going with a single point, I am trying to form an interval range. Now, how do I know? I have to logically group the data 10 and then compute the average and the domain knowledge. Yes, this is the domain knowledge. What is the domain here? The traffic. I know 10 o'clock is the busiest, 11 o'clock is not the busiest. And why average? Why not median? Why I should not rely on 40? Why I should form an interval 40 to 60? Why I should tolerate? Tell me.
because it's okay if it's
Okay, at plus 10 minus 10 is okay, right? So that's where your domain knowledge helps you. It's not that straight away you approach the problem. Domain knowledge will help you a lot, okay, to solve the business problems. Okay, this is something you have to understand. Okay.
Definition of
Everything should converge, guys. Okay, your data understanding should converge, your mathematics should converge, your Python and your domain knowledge, everything should converge at one point. Then only you will get a better result, better yield. Okay, all of this. So now in real time, how you will get domain knowledge? Tell me. Let's say you are working on a company. There is something called client. They contains the subject matter expert. So this guy is there in the industry from 10 to 20 years. This guy knows everything. You can put 100 questions to this guy and you try to understand this domain knowledge from this guy. Okay. The business problem. What is business problem? What is the? It's not that you simply know the business problem. What you have to understand? What is the business problem? Earlier, what they are doing? Earlier also they have the same problem, right? Okay, let's say they want to understand what are overall speeding. Now they want to use ML. But before, what they are using? To understand the person diabetic, yes, no. Now they want to use ML techniques. But before, what they are using? What is the earlier approach? What are its limitations? Why it's not working? Why your ML is effective? Okay. By using ML, how I can effectively solve this problem? Okay, you have to understand the business problem and the context correctly. What are they previously doing? Why it is not working? Why they want to move to the ML? How they know that ML is a good solution for this and all. So you should understand the business problem correctly. In what way this is benefiting them? Okay, so upon solving this problem, what is the profit they are getting? Here they are reducing the manual effort. For every 1,000 patients, only 10 patients they are getting business. They don't want to put manual efforts to perform tests for these 1,000 people. Instead, they want to simply give to the ML. ML will take care of all this. So here they are reducing the manual effort. By reducing the manual effort, they are getting the cost advantage. Okay. In what way? By solving this problem, it is benefiting the customer. You should understand that point as well. These and all you will not get from the course. Okay. As an experienced guy, I'm trying to tell you. Once you move to the project and all, these things will help you. Okay. And what is the next thing? You should have a strong mathematical knowledge, maths knowledge. Okay. How to make, when to use which solution. It's not that I use mean all the time. It's not that I use median all the time. It's not that I use mode all the time. Sometimes I have to use mean. Sometimes I have to use median. Sometimes I have to use mode. These things I will cover in the data analysis. When to use what, how to approach and all, I will try to tell you. Okay. When to approach, how to approach that problem and all, we will try to see in the course. Okay. Python, I would say Python is the least, fourth ranking. Okay, maths is the primary skill. Second is the business problem. Third is the domain knowledge. Okay, Python is why Python is the fourth. Tell me.
Because the actual coding is very easy.
Coding is very easy, guys. If you go to Google and if you ask, it will give you code. Okay, you don't need to code, and the functions will take care of everything. All you have to know is mathematics first. Okay, so everything is important, but I try to rank it. Okay, understood? Daily, before you come to class, revise before class and come, because everything will be a continuation. Come with curiosity. Come with the mindset that I'm going to learn something new today. Okay. Okay. What is the ideology you should have? Come with the mindset that today I'm going to learn something new. Come with excitement. Come with curiosity. Come with questions. Ask. Try to ask more questions. Learn more. Okay. The more questions you ask, the more you don't get feared. Okay. Feel free. Feel friendly. Whatever you want. If you want to break, feel like having a break, ask for a break. If you feel like not having a class for today, or if you want to cut short, then you feel free. Okay. So curiosity is the most important thing. Okay. But you should be curious, infinitely curious. Then only you will learn more things. Okay. Yeah. Do your work. Come with questions. Practice. Not only practice. Okay. Let's say if I put a question, if I teach a concept today, like let's say if I taught you lists, try to go and check interview questions on lists. If you simply type give me some interview questions on lists, it will give you, and try to answer on your own. Okay, try to prepare this question, that will help you. Let's say if I'm telling course for 50 days, guys, daily if you are preparing 10 questions, how many questions is it to the say 500 questions? If you interchange your questions among themselves, that's how many questions? 2000 questions. Yes or no? By the end of this course, what will happen? You know how to answer a question. Yes, right? You should have the idea. Okay. So how do I know this? Tell me. If I prepare 5 questions every day, that's 500 questions. You should get the idea in the mind. Okay. Let's say not only verbal, you have to both answer verbally and technically. In an interview, they will ask you what is list, and technically also they will ask you create a list, try to access the first element. So you have to prepare 5 verbal questions and 5 coding questions. Okay, like that you have to do. Understood? So 20% is my effort, 80% is your effort. Understood? Practice, yeah, that's the only way. Simply,
practice examples too.
I can give, see, okay, I will tell you. Let's say I'm giving 20 questions to you guys, but this 20 I'm giving to you 4, correct? But if each of you prepare 20 questions, what is happening? 20, 20, 20, 20. 80 questions. It's a teamwork, guys. It's not one person's effort. It's a teamwork. See the difference? How much is the difference? Understood, brother? See, it's a teamwork. We should work as a team. Don't rely everything on me. If you learn whatever I'm telling on the class, you'll only get 20%. If you go home, practice, you will get a 80%. Understood? The class is only 20%. You should explore. Understood? See, this 20% how I'm seeing Python. But if you go to Google, there are many people has many views. How they are seeing Python, you should also learn that, right? They ask you that in the interview. Understood? Here, I will stop here. I think we are good for today.